Hello and welcome to Building Codes Illustrated. Today we're going to take a look at occupancy types and we're going to be checking out our next PowerPoint. Let's go in here. Okay, keep going. Can't find it right off the bat. Each occupancy group has defined specific requirements to how high can we go with it. Can we take that building out to the lot line and how many stories can we go high up? And how much parking is going to be available with this, and what's the means of egress? How do we escape from this in case there's a fire? Fundamentally, use occupancy based. So we just came from talking about the classification types. We'll let that soak and sink in. In the code book, it looks like this. We want to check out the language. Uh, Assembly Group A uses intended for gathering together persons such as civic, social, religious functions, recreation, food and drink consumption, or waiting transportation. A room of less than 50 persons used for assembly but is accessory to a different occupancy shall be considered that different occupancy. So it always talks in vague terms, and the purpose is that you will get to interpret these terms, hopefully not in a court of law. But you determine what's happening to determine the occupancy group for that use of the building or portion that it most nearly resembles. What does it most nearly resemble? Compute the floor area and the occupant load of the building and the portion thereof, and see the appropriate sections in Chapter 3 for buildings with mixed occupancies. We also need to know the type of construction, or we will get the type of construction that we need to do to make these hour codes. Make sure that we can get the rating 1, 2, or 3 hours that we need. 1B, the type of construction. Determine the type of construction by the materials used and the fire resistance of the parts of the building. Construction type. Construction types are categorized within their resistance to fire and structural applications. Construction types give some indication of the amount of time available for the evacuation. So we have our construction types 1, 2, 3, 4, and 5, and typical kinds of pieces of structure that are used. We have an enclosed beam on 1, an exposed beam on 2. We have could be a wood board with wood posts, could be a timber post here, and then our traditional stud wall. So it says the increasing fire resistance and cost versus decreasing occupancy and cost. So it's going to be a graph. So depending on what kind of materials you use, the more resistant construction types are allowed to have more occupants, larger area, and more stories. The rule of thumb: occupancy, quantities, and construction costs will both decrease with building type from type 1 to type 5. Chapter 6 and Table 601 gives a synopsis of the minimum fire requirements for each main element of a building. Okay, so here's the hour types, and then here's the type of buildings up at the top. These charts I would take a little getting used to, and you can see that their ratings. Structural frame for a type 1 has to be a 3-hour. Fire construction, including support beams and joists. Also, a concern and part of zoning is you have to determine the location of the building on the site and the clearance, so property lines and other buildings from the plot plan. Determine the fire resistance requirements for exterior walls and openings and requirements based with proximity to the property. Establish permissible area for each floor for each use and the entire building. Some types of construction are limited in size based on occupancy and concentration of people. The allowable height and areas are tabulated in the grade table 503. Let's look at 503. Okay, so we have our group types on the left, and then we have Sizes per the pad itself is shown. Let's go back up. The building floor area is shown of how much you can get out of it. The height and number of stories. You compute the height of the building and determine the number of stories. Determine the maximum height and number of stories permitted based on the occupants group and the type of construction. Determine allowable height and story increase based on the installation of approved automatic fire sprinkler system. So anytime you want to go larger and you have to be safer, they're going to include this fire sprinkler system. So that's the complete package of how we're gonna get all these parts. We're gonna do our occupancy type. We're gonna do our what is the occupancy, and then what is the type based on materials. What is the site plan? What is the floor area, and then what is the floor height? All of these we're gonna start in that procedure. Classify the building according to the occupancy, type of construction, location of the property, floor area, height, and number of stories, and then look it up in the chart. Review the building for conformity with occupancy requirements. Review the building for conformity with the type of construction. And it's all review. Review the building with the egress requirements. Review the building for other detailed regulations. And review the building for conformity with structural engineering and regulations. There are also more code components that you often run across, which are the definition of exits and egress, building separation and shafts, fire protection standards, and fire extinguishing systems. What is egress? Egress is escape. So every building, every room usually has that red sign or a green sign that allows you to know where to run. And there's a measurement. Each building also has a measurement. Someone has calculated from that door how many feet is it to the outside exit door till you're out the door and free from fire. Determining egress requirements and provision for safe means of egress is one of the most important functions of building codes. There are specific requirements for size, space, and travel distances, and components such as floor plans, doors, corridors, and stairs. Building separation and shafts, two big things to look at. If you have mixed occupancies, many people are living in that townhome. So maybe there's two families. They always have to have a separation. You might also have a building where downstairs is a good drawing. On the handout, I had floors such as stairs, elevators, mechanical shafts can allow the passage of smoke, heat, and flames. Hence, codes have the requirements based on occupancy, building type, and building height related to shaft protection. So we're really discussing what's causing this limit, this pull down to our heights that we can get. It's these kind of things. Fire protection is divided into two categories. There's passive or active. Passive protection is one built into the structure, which means the materials, the walls can be that's built in, the protective membranes, the wood, steel, reinforced concrete, combustible or non-combustible, all the things that we do to seal and improve the material add to that. Active protection is one where the fire causes a reaction in the sprinkler systems that serve to combat the fire. And these are sprinklers. Also, doors that might open and shut are good. Code analysis and design often includes the trade-offs between area or occupancy separation rating, requirements of how long will it take for a fire to penetrate a wall, partition, a floor, or a roof assembly, and flame spread, smoke generation, requirements of how long it takes a fire to move along the surface of a building, and how much and what toxicity is the smoke is generated. How about this one?
On arrival, we had visible flames from the roof. We accessed the roof quickly and saw fire coming from one of the vent stacks. We also made entry on the interior, and when we started removing ceiling tiles, we found superheated gases and fire up in the concealed space. At that point, we decided to exit the building, and at that point, the fire broke through the roof and vented itself, and the fire spread quickly. It's been here since the mid-1970s, and it's been remodeled several times. When they remodeled it, rather than removing the existing ceiling, they just go ahead and put in another drop ceiling. Well, we had to remove the suspended ceiling tiles to get to the fire, and when we did that, we ran into another ceiling, which delayed our suppression efforts, just getting access to the fire. Big fancy trucks and water, they don't mean anything if you can't get the water to the fire. So that delayed our suppression efforts until we could actually get access to the fire, to the structure, and then once we applied the water.
That because restaurants have this history of failure that they're always looked at, and that's one example where also when you're doing a renovation, if you take a shortcut like they covered there, they just added the new roof without taking the old out. Right? There's hidden traps. All kinds of things can happen. Fire resistance standards include the structural hour rating. How long does it take for a fire to weaken the structural element to a point of failure? The minimum time for evacuation and firefighting response. The area or occupancy separation rating. Requirements of how long will it take for a fire to penetrate a wall partition, floor, or roof assembly. And three, the flame spread and smoke generation. Requirements of how long it takes a fire to move along the surface of a building and how much and what toxicity the smoke is generated. Okay, so we do have the fun of going into more fire codes, which enlivens things up a little because buildings, there's usually one central location now that contains all the things that the fire department needs. It usually has a digital coded map of different parts of a building that might even show where the fire is taking place at. The use of such systems often results in trade offs for additional height or area. This trade off is how you can get a bigger building. Trade offs only apply when systems are not otherwise required by the code. The idea of a trade off recognizes that this is a mitigation measure over and above the basic code requirements to achieve the desired level of safety different from those spelled out in the code. Engineering requirements. One of the bases of codes is a structural adequacy of the building for both static loading, such as occupants, equipment, as well as dynamic loading, such as earthquakes, snow, and wind. So we talked about live loads and dead loads. Every project, no matter how small, should have a code analysis performed. And whenever possible, consult the building department and other AHJs prior to the design. Do not expect the code official to do the analysis work for you. Remember, compliance is the responsibility of the designer, not the code official. But there are many levels of people who put together a package when you're creating a building that can help. Codes are subject to interpretation, so it's always in your best interest to determine what, if any, interpretations will be needed for a project. Remember, do not try to memorize parts of the code. Remember where stuff's at, but codes can change every 3 years. There can be an addition. As sections change and interpretations alter meanings, such as memorization is a recipe for future trouble. Clients may expect you to rattle off code requirements, but it's not in the best interest of a project or client to do so and possibly make snap code decisions. Do not proceed on memory or past experience from other jobs.